Okay, in this video we're going to look at two of the fundamental laws of logic, the law of detachment and the law of syllogism. The law of detachment says that if a conditional statement is true and if you have another statement that matches the hypothesis of the conditional statement, then you can make a statement that matches the conclusion. So let's take a look at a couple of examples of the law of detachment. Example number one. If someone has the flu, then they don't feel well. So that's a conditional statement, and it's true. If someone has the flu, then they don't feel well. And then I have the second statement that I'm told, Lindsay has the flu. Well, I notice that this statement matches the hypothesis of my conditional statement. The hypothesis of my conditional statement is someone has the flu. Well, here I have a specific statement about somebody, Lindsay, who has the flu. Well, since I have this statement that matches the hypothesis of my conditional statement, I can draw a conclusion. That is, I can make another statement that matches the conclusion of my conditional. That is, I can say Lindsay doesn't feel well. Example number two. The given conditional statement says, if two angles are vertical angles, then they are congruent. I know that's a true statement. So I have a true conditional statement, and I'm also told angle A and angle B are vertical angles. That is, I have a specific statement that matches the hypothesis of my conditional statement. Angle A and angle B are vertical angles. That matches the hypothesis of my conditional statement. Well, since it matches the hypothesis, I can make a statement that matches the conclusion. That is, if angle A and angle B are vertical angles, then I can say angle A and angle B are congruent. And that's the law of detachment. Now, notice that it's important that the statement that you have, whatever it is that you're told, it's important that it matches the hypothesis. Take a look at example number 3. It says, if it is snowing, then the temperature is less than 32 degrees Fahrenheit. So this is a true statement. I have a conditional that's true. And then I'm told the temperature is 20 degrees Fahrenheit. And I'm asked, what can I conclude from this? Well, notice that this statement here, it does not match my hypothesis. It does not match the hypothesis. My hypothesis is it is snowing. This does not match the hypothesis. In fact, this matches my conclusion. So since this does not match the hypothesis, I cannot draw any conclusion at all from this. All right, so I can say, what can you conclude? I can't conclude anything. No conclusion. Example number 4. If x is an integer, then x is a real number. Now you may recall that the integers are numbers like, say, -2, -1, 0, 1, 2, etc. Those are integers. So if x is an integer, then x is a real number. So that's a true statement. So I have a conditional statement that's true, and I'm told x is a real number. Well, notice once again, this that I'm told, it does not match the hypothesis. My hypothesis of my conditional statement is x is an integer, and this does not match my hypothesis. In fact, once again, it matches the conclusion. Well, since it doesn't match the hypothesis, what conclusion can I draw? I can't draw any conclusion here, because this does not fit the law of detachment. Notice in particular, I can't say that x is an integer. Just because x is a real number doesn't mean x is an integer. For example, x could be equal to 1/2. That's a real number, but it's not an integer. So that's why I say I can't draw any conclusion about x just based on the fact that it's a real number. this statement, this that I'm told, does not match the hypothesis of my conditional. Example number 5. If someone is wearing Vans, then they're wearing shoes. That's a true statement. Vans are a particular type of shoe. I'm told Tamarius is wearing shoes. What can I conclude from this? Well, again, I can't conclude anything because, once again, this part that I'm told here, this does not match my hypothesis. The hypothesis of my given conditional is someone is wearing Vans. This statement here, Tamarius is wearing shoes, it does not match my hypothesis. In fact, again, it matches my conclusion. So I can't draw any conclusion based on the fact that Tamarius is wearing shoes. And in fact, in particular, I can't say that Tamarius is wearing Vans because he might be wearing Nikes or Reeboks or Converse or something else like that. So once again, here I have no conclusion. Now, the law of syllogism. The law of syllogism says, given two true conditionals of the form if A then B and if B then C, then we can say if A then C. Now, a lot of people like to think of the law of syllogism as kind of taking these two statements, if A then B, and if B then C, kind of taking these two statements and squashing them together into one statement. If A, then C. And you kind of, when you squash them together into this one statement, the B parts kind of go away. So let's take a look at some examples using the law of syllogism. Example number 6. If Henry studies his geometry, then he will pass the test. And if Henry passes the test, he will get a good grade in the class. So here I have two statements, and they're both of the form if A then B. If A then B. This one is of the form if B then C. Notice this part here, the hypothesis of this second statement matches the conclusion of this first statement. So I have these two statements, if A then B and if B then C. What conclusion can I draw? Well, I can say if Henry studies his geometry, then he will get a good grade in the class. So I've just taken these two statements and kind of squashed them together into one statement that leaves out the B part. Example number 7. If someone lives in Siler City, then they live in North Carolina. Second statement, if someone lives in North Carolina, then they live in the United States. Well, again, I have two statements that are of the form if A, then B, and if B, then C. Notice how these two parts here, the B parts, they match up. They live in North Carolina, someone lives in North Carolina. So I can say, I can essentially take these two statements, squash them together using the law of syllogism, and I can say if someone lives in Siler City, then they live in the United States. Example number 8. If a number is a whole number, then it is an integer. If a number is an integer, then it is a rational number. I have two if-then statements. If A, then B. And if B, then C. Once again, I can take these two statements and I can combine them into a third statement that says, if a number is a whole number, then it is a rational number. And that's the law of syllogism. Now, one of the things that we mentioned, that the law of syllogism, the second statement, the hypothesis of the second statement is just the conclusion from the first statement. And that's how you know that you've got the if A then B and if B then C format. Now, something else about the law of syllogism, the law of syllogism actually matches very closely a rule from algebra, one of the properties of algebra that you've studied before. And I want you to see if you can remember what that is, and we're going to talk about that some more in class tomorrow.